Okay, so because of the movement of H plus ion between the glass electrode and that of the unknown solution, okay, because of the movement of H plus ion between the glass electrode and that of the unknown solution, there will be change in the potential between the two electrodes. So which would be recorded by the inbuilt potentiometer. So whatever potentiometer reading is there, that is being converted electrically, and you get a unknown reading solution as a digital display. So knowing the pH of the solution, its hydrogen ion concentration can be calculated. Is it clear? Anybody has any doubt? Have you understood, or you want me to repeat?
Understood, ma'am.
Understood? All of you understood? Anybody has any doubt? Any doubt?
No, ma'am.
No? Is it confusing? Please let me know. I'll explain. All of you have followed? Only one said yes. Others? All of you have understood? I'll assume you have understood, or how is it?
Yes, ma'am.
Understood? But the yes is coming very slow, as if partially you have understood. If you have doubt, please ask. If you have not understood, please ask. I'll repeat. There's no problem. Yes? It's not coming confidently. Yes, ma'am, understood. No, that's not coming. Anyways, it's not a normal class to just make out looking at your faces. It's virtual class, so I'm unable to find out. But I can find out because of your voice. Yes? Understood?
Understood, ma'am.
Okay, fine. Now I can find like yes, you have understood. Okay? Okay, moving on to next. Why should we study pH? What is the significance of pH in pharmacy? So after finishing this, we'll stop the lecture. So in general, whenever a medium contains water, as we know that water acts as a amphiprotic substance, that is, it can act as an acid as well as base. Say now whatever product we have has water content in that, so it can itself act as an acid or a base, right? So there can be change in the pH during its storage conditions. So we have to consider the pH, especially in those cases wherever it is, especially for parenteral use. What is parenteral? What are parenterals?
Injections or whatever you use, ma'am.
Right, injections or anything which is directly introduced into the blood. Okay, various injections are parenterals, wherein the pH has to be maintained. Not only injectables, that is parenterals, as well as ophthalmic solutions. Very important, these two products, wherein we have to consider the pH as a top priority. Okay, next is for the stability. As I said, for the physiological activity and optimum stability, the pH has to be controlled, or else what happens, it can lead to degradation of the product. I'll give you an example. For example, there is a glass in case of parenterals or any other, known as soda lime glass. Okay, there is glass known as soda lime glass, which is made up of sodium ions, wherein if at all, if you keep any product, for example, I am having some acid, assume that salicylic acid as a product. Okay, salicylic acid. So what happens if I'm storing this salicylic acid along with this in the soda lime glass bottle, is that eventually, that is, as the time goes on, this particular soda lime dissociate itself. Okay, this soda lime glass dissociate itself, and the sodium ion present in the soda lime keeps entering into the salicylic acid or inside the product. So what happens to salicylic acid? It's an acid. So what happens if you are introducing sodium ion? Sodium ion is actually a base. So what happens?
It gets
Acid and base reacts, resulting in what?
Formation of salt.
Right. So what happens? The salicylic acid now forms sodium salicylate, which is a salt. But what was the preparations I made? It was salicylic acid. Can you take sodium salicylate instead of salicylic acid? No. So whatever stability during the storage as well as for the activity. So whatever activity shown by salicylic acid is different from that of sodium salicylate. So in general, for the physiological activity as well as stability, pH has to be controlled or maintained. In that case, use of soda lime glass is avoided and use of borosilicate glass or any other glass is being used. It's just an example. So during the course of manufacture, pH of the product can be influenced by various ways, and knowledge of more important factors is useful in formulation of such products. Precipitation can occur if the pH of the solution is changed significantly, as I gave the example. So for all these cases, this is the same thing. So sodium benzoate, benzoic acid. So such can result. Okay. Purification of proteins is simplified. Amphoteric compound shows minimum solubility at isoelectric point, and in certain pHs you find there is precipitation of certain compounds based on change in pH. So it's basically based on again degree of dissociation of the compound based on the change in pH. Not only that, for general activities, if you say now if you're taking any drug, so whatever drug you take, it dissociates into ions, right? So certain times, most of the cases, only unionized form of molecules can penetrate into the cell membrane. If it ionizes, what happens is that the ionized form of drug will interact with the cell membranes, which is charged. So there will be repulsion and all, because of which the activity will not be shown. For any drug to show its action, it should be in unionized form. Okay, so again, maintenance of pH matters here for the biological activity. For the medicament to show the biological activities, they have to be in unionized form, because as they enter the cell membrane, if unionized are there, that means there is no charge, so there will be no repulsion. But if at all if they ionize, what happens is that repulsion takes place and the activity will vary or it decreases. Okay, because ionized will not show any action, so you'll not get any activity. So in case of acridines, maximum effectiveness is seen when the drug is in ionized form. Okay, so that is pKa when it is equal to pH of the body fluids. So enzymes have maximum activity and stability at different pH values, or certain times you see that enzymes get destroyed because of change in pH. They might turn inactive, or certain times they might get destroyed. For example, insulin, if you take, how is insulin being taken? Anybody? Have you ever seen or heard of people taking insulin? In which route are they going to take the insulin? Is it insulin
Intravenous,
tablet?
Parental, ma'am.
Right, parenteral. It's not
IV.
intravenous. No, it's not intravenous. It is subcutaneous, HC. Okay. Intravenous, if you give, what happens, I'll tell you. It is given to the underneath the skin. It is not to the veins. Okay. That's okay. In general, it is not intravenous. That is insulin, whatever people take it, it is to subcutaneous route. That is to the skin. Underneath the skin, they are going to take it. Why? Because if at all if it's been taken intravenous route, it directly enters the blood, right? So directly you observe that the patient's glucose level goes down immediately. Thereby you see that people will faint off if at all if it's given through IV route. Subcutaneous, what happens is that slowly there will be release of the insulin in the blood slowly. So it will be helping in maintaining the metabolism. Okay. So in general, why is it not given through oral route? Why can't insulin be taken in the form of tablets? The problem is that insulin it's a protein. Okay, it's made up of a protein, so which has been broken down by the enzymes which are present in the gut, like pepsin, renin, all those are protein enzymes. So these enzymes act on insulin and break them. Okay, and break them before they show the action. So what is the use of insulin now? No, because it's already been destroyed. That is why insulin, you cannot take it through oral route. That's why you give it through subcutaneous route. If you give through subcutaneous route, it will enter into the blood slowly. So in the blood there is no such enzyme which can inactivate them. But if you take it through oral route, these protein enzymes will act on that and break them down. Thereby insulin will be destroyed. Clear? So enzyme activity, pH matters a lot. So many compounds which are unstable in aqueous pH can be stabilized by adjustment of pH also. There are cases, and injections are adjusted to a definite pH to ensure stability of the product. Not only this, if pH varies in case of injections and ophthalmics, you observe that there is irritation, itching, and untoward effect. Okay, so this is about the pH and importance of pH in pharmacy. Any doubt till here? Have you understood different methods of determination of pH and use of pH? Is it clear? Am I audible? Is it clear?
Yes, ma'am.
Have you understood? Anybody has any doubt? You can ask. No? Nobody has any doubt? Okay. So buffers, we'll do it in next class. Okay. Thank you.